Alright, so this is day 2 of verifying trig identities. So remember, when we are verifying them, we're just trying to say that the left side equals the right side. So whatever seems to look more complicated, that's going to be the side that we're going to try to reduce down and make it equal to the right side. So how can I make 2 minus sine squared theta minus cosine squared theta equal to 1? Now notice these are not being multiplied to each other, so we're not going to break them down in terms of sine and cosine. That wouldn't matter anyway because they already are in sine and cosine. However, we do notice that we have sine squared and cosine squared. Anytime we have something that's squared, we want to refer back to our Pythagorean identities. So the one that uses sine squared and cosine squared is going to be up here. Now notice it's a positive sine squared plus a cosine squared. That's what equals 1. Well, I have a negative sine squared and a negative cosine squared. How do I get rid of that? One way I could do that is by factoring out a negative 1. And so what happens is I have this 2 brought down, and I'm going to factor out a negative, and when I do that, my negative sine squared becomes a positive sine squared, and my negative cosine squared becomes a positive cosine squared. Now, why does that help us? Because I took a negative sine squared and negative cosine squared by factoring that out, and I made a positive sine squared and a positive cosine squared. And what does a positive sine squared plus positive cosine squared equal? Well, it equals 1. So, therefore, I can replace what's inside my parentheses with 1. Sine squared plus cosine squared is equal to 1. And what is 2 minus 1? Well, 2 minus 1 is 1. And so, therefore, that does equal the right-hand side. Now, what about this number 2? So, in number 2, we're not multiplying really, well, we are here, but notice we have the cosine squared and the secant squared, so we want to try to deal with that. Now, where am I using cosine squared? I'm using that up here in number 1. I'm using secant squared down here in number 2. So I want to use secant squared. That's inside the parentheses. I also notice that negative 1. How can I get this secant squared x minus 1 to match this secant squared up here? Well, I think the easiest way is going to be to subtract 1 from both sides. And when I do that, I'm left with tangent squared is the same thing as taking this secant squared of theta or x minus 1. And so now I see, oh, secant squared minus 1 is the same thing as tangent squared. So I can go ahead and replace my secant squared x minus 1 with tangent squared x. And again, trying to see, does this equal the right-hand side? All right, now how does that help us? Well, now that we are multiplying officially with no pluses or minuses in there, let's go ahead and break everything down into sine and cosine. So we get cosine squared times tangent is sine squared, that's a 2, over cosine squared. So now I have a cosine in the top, because it's over 1, and a cosine in the bottom, and those simplify or reduce out to be a 1. So what's the only thing I have left over? I have a sine squared x. The problem is that doesn't equal 1 minus my cosine squared x. So how do I deal with that? Because I need the left side to equal right side, and I cannot manipulate the right side because I started with the left. Well, again, if we go back up to our first Pythagorean identity, we already noticed that it contained a cosine squared, which is now a sine squared. So how can I replace sine squared with something? Well, what does sine squared equal? If I leave this alone and I move this cosine over to the other side, what I get is sine squared equals, after I subtract cosine, I get 1 minus cosine squared theta. Therefore, sine squared is the same thing as 1 minus cosine squared. So I can replace this with 1 minus cosine squared x, and that does equal the right-hand side. So a lot of this I know can be challenging, but first step, if you're only multiplying, look to change everything in terms of sine and cosine. Second step, or second thing to look for, is if you see these cosine squareds or secant squareds or anything squared, look at your original 3 Pythagorean identities to try to help manipulate and change that to be something that is more useful.